Okay, today we're going to talk about complex numbers. Not all quadratic equations have real number solutions. Remember these? Sometimes we got a parabola that did something like that. And then we wrote there was no solution. Well, we're not going to write no solution anymore. We're going to find a solution. And it's going to be a non-real solution. The reason being, so if you looked at this parabola, x squared, well, if this was x squared equals -1 and you were trying to solve that, you would say x equals plus or minus the square root of -1. And then if you push that on your calculator, right, turn that program off. We've tried this one other time when I mentioned that that was something we couldn't find the answer to. Well, if you go second x squared, the square root of -1, and we hit enter, we're going to get non-real answer. Okay, so now we're going to teach you how to find an answer. All right, so we're going to realize and learn today that the square root of -1 is this fancy number that mathematicians came up with. They expanded the number system. Yeah, into letters. Ooh, isn't that? I know kids love that, don't they? Into letters. All right, I is the square root of -1. These are the two most important things to know today. And I squared is equal to -1. So this imaginary unit I can be used to write the square root of any negative number. Oops. The square root property. The square root of a negative number, if r is a positive real number, then the square root of -r is I times the square root of r. You got to pull out your I. It hurts, but you got to do it. So we want to memorize that the square root of -1 is I, and that I squared is -1. Super important concepts. That's why I highlighted them a minute ago. And then the other thing would be to remember that this list right here, and I'll talk about that again in a minute after I go over those examples up there. So what I got up here, the square root of -5 is I times the square root of 5. I times the square root of 5 quantity squared. You have to square both the I and the square root of 5. When you square the square root of 5, you get 5. So then you replace the I squared with a -1, and that's how they got -5. This pattern right here is really important for you to memorize. Okay, you have to know those four. Once you go past the fourth power, it repeats. Okay, all over again. So, what if you had, and I'm going to show you some of these examples later, I to the 40th. Well, how many I to the 4th is that? Okay, so it'd be I to the 4th to the 10th, agreed? So that's using back here. Oh, that's not there. I had a warm-up before I was going to show you. But anyway, that is I to the 4th, which we will memorize is 1. 1 to the 10th is 1. So what would I to the 41st be? Isn't it just this with an extra I? Get what I'm getting at? So if I do 4 goes into 40 evenly with 1 left over, the answer is I to the 1st, which is I, or the square root of -1. So backing up a minute again, I to the 42nd, what would that be? I to the 40th times I to the 2nd. This is 10 ones. This is just 1. Any power of 4, I to the 4th is 1. This is just 1 times I squared. So this answer would be -1, because I squared is -1. So here's my point. There's only 4 answers possible. That one, that one, that one, or that one. Okay? So what would this be? This would be I to the 40th times I to the 3rd, which is -I. Pardon me? What do you mean the rest of them? Here? They're just the next set of them. It repeats every 4. That's why I'm showing you only need to know the first 4. Okay? This just repeats again. There's only 4 possible answers. Okay, and they're all, I'm going to do some more examples, but the point was I just made these up. I'm trying to get you to understand that if you divide by 4, the remainder is the power of I. That's all you got to do. Okay, see, 40 divided by 4 is 10 evenly, no remainder. So the answer is 1. It's I. It's just 1. I to the 4th. I to the 4th, 1. If you get a remainder of 1, you get I. If you get a remainder of 2, you get negative 1. And if you get a remainder of 3, you get negative I. Okay, just those. So we're going to have to memorize those. We'll try it again in a little bit. Let's try something else first. Let's look at how we simplify the square root of negative 49. Well, you pull out your I, ouch, and then you take the square root of 49, which is 7. So this would be 7i. And no, you don't have to write that step right there. So what's the square root of negative 4? Well, it's definitely not 2, but it's 2i. And this one, square root of negative 7, is I times the square root of 7. And negative 5i squared would be, now you got to do separately, negative 5i. You can write it like this if you want. Okay, but negative 5 times negative 5 is 25. I times I is I squared. And I squared is negative 1. So this answer is actually negative 25. So the first time you have squared something and you get a negative. And that's because we're dealing with imaginary numbers or complex numbers. Okay, a complex number is any number that can be written in the a plus bi form where a and b are the real number. A and b are real numbers. A is the real part, bi is the imaginary part. So name the real and the imaginary part. I'm just going to point at them. Of course, the 7 is the real part. The part with the I is the imaginary. And number 6, 8 is the real part. Negative I is the imaginary part. But on number 7, we can separate that. Whenever you have a sum or a difference in the numerator with a whole number denominator, you can separate this into fractions. That'd be 5/7 I plus 2/7. This is the imaginary part first, and the real part's the 2/7. Okay, and on 8, 2 is the real part, and I times the square root of 7 is the imaginary part. Anybody still need this? Okay. Did I go too fast for you? Sorry. Was it this part? Do we have trouble with what I wrote here? Wait, do you want me to re-explain that right here? You just put each part over 7, separate it, okay, into a sum. Okay, next. When adding or subtracting, carefully make sure you know what you're doing here. Adding or subtracting complex numbers, you're going to combine like terms. Combine the reals and the imaginaries. When multiplying complex numbers, don't forget that I squared is negative 1. Super important. So what we do when we do number 9 is we drop the parentheses, and then we look at the terms and combine like terms. Negative 3 plus 6 would be 3, and I minus 3i would be minus 2i. Number 10, drop the parentheses. I do have addition, so I don't have to worry about much when I drop the parentheses. It's when I have a subtraction that I do. So now I say negative 8 minus 8 is negative 16, and then the i's are opposite, so that drops out. On 11, careful. When you subtract, don't forget, you have to make sure that you distribute the minus sign. So 2 minus I minus 3 minus 2i is that when you drop the parentheses, that's what you get. You need to distribute that minus sign. So I combine my like terms. 2 minus 3 is negative 1, and negative I minus 2i is negative 3i. Okay. Did I write? No, it should be minus 2. Because it says to subtract. That's why I say you have to distribute the minus sign. Absolutely. Absolutely. That's been the most common mistake back when we were simplifying. You know, anytime you subtract anything in parentheses, whatever's in that parentheses changes sign. Okay? So if it was minus a 3 minus 2i, that would become minus 3 plus 2i. Okay? Down here, it was minus 3 plus 2i, so that'd be negative minus 3 minus 2i. All right, so on number 12, we are distributing the minus sign on the second parentheses. So you should have negative 7 plus 2i minus 4i plus 5i. That gives us negative 11 plus 7i. Do I need to slow down? All right. Now here it comes. This says to multiply. You got to be very careful. On the first quiz we have on this next Friday, people will forget about distributing that minus sign properly, or they might add instead of multiply, or they might subtract or something instead of or multiply instead of add. So be careful. Parentheses are butted up close to each other. We're going to multiply it out. So we're doing 3 times everything in the second parentheses, negative 12 plus 6i. Then we're going to multiply I times everything in the second parentheses, giving us minus 4i plus 2i squared. Okay. Combine your terms in the middle. We got negative 12 plus 2i. And then I changed the I squared to a negative 1, replacing I squared with negative 1. We got to remember I squared equals negative 1. Our final answer for number 13, I don't know why I've made this so crowded, that'd be negative 12 minus 2, which would be negative 14 plus 2i. Okay, and the next one, our conjugate, they're conjugate pair. See how they're opposite only in the middle? They're not opposite, they are just opposite sign in the middle. So there should be some middle term dropping out. 5 times 5, we get 25 minus 10i for the first product set. Distribute 2i over both things in the second parenthesis would be plus 10i minus 4i squared. The middle two terms are opposites. Bye-bye. So I've got 25 minus 4 times negative 1. I replace the I squared with negative 1. That gives me 25 plus 4, which is 29. Okay, now careful on 15. The tempting thing to do is multiply and then simplify, but it will be wrong. If you have 3 root 5, it's not correct. Okay? You got to pull out your eyes first. Oof, both of them. Okay? Now I've got I times I, which is I squared. 15 times 3, or 3 times 15 is 45. Square root of 45 is 9 times 5. Square root of 9 is 3. And this I squared is negative 1. So the answer is negative 3 times the square root of 5. Okay, all I did was simplify the radical. And I squared is negative 1. All right, let's multiply the guys on the outside. 5 and 2, we got 10. Oh, don't forget my i's. See, so I've got I times the square root of 2 and I times, well, that's 4i, right? I can do this a bunch of different order. That's 4i. I went ahead and did the 2 times the 5. Brought out my I. Did the square root of negative 16 is 4i, and now I got to just multiply this stuff. At 40i squared times the square root of 2. I squared is negative 1, so this would be negative 40 squared to 2. Do you want me to do that one a different way? I can. I'll get the same answer. Okay, so let me show it again. Let's just do, I'll pull out the I. Square root of negative 16 is 4i. Is that good? Maybe that helped a little bit. Okay. 5 times 2 times 4 would be 40. I times I squared, square root of 2. And then now I got my negative 40 square root of 2. Is that better? Okay. Either way is correct. It's just, I think you guys saw that better that way. All right. This would be negative 12i. And then I got I squared, which is negative 1. So this answer is actually positive 12i. I didn't want to multiply the I times I squared because why bother? Yes. Oh, yeah, my fault. On your equations, guys, somehow I've already made a note to change that worksheet out for a different copy because apparently when I printed it off, the font didn't come up properly in the computer that printed it off, and it put an infinity symbol, I think, or something. Infinity? Is that what you guys have? Sorry about that. It's the times. Sorry, multiply. It was a font that it didn't recognize when it printed. So sorry. So just please omit that. All right. Here's the harder part. This part of the lesson is just a little bit harder than the other part. For this lovely word, conjugate. We had, remember the square root of 2 minus 2, the conjugate was the square root of 2 plus 2, okay? Or x minus 2, the conjugate is x plus 2, okay. These we want to multiply both the numerator and denominator by the complex conjugate of the denominator. So ignore the numerator, have a look at your denominator. I want to get my eyes out of the basement because they're weird. And just like rational number, the square root numbers, we didn't want irrational people in the basement. We got them out. All right, we're going to get my eyes out of there too. All right, so we're going to multiply by 2 plus I. And what you do to the top, you must do to the bottom. Or the top and the bottom have to have the same thing done to them. If you do it to the bottom, you do it to the top. So we're going to have to do some multiplying. We're going to multiply 5 times both terms inside that parentheses. It's going to give us 10. Plus 5i. I got to tell you right now, if you're a person who likes to skip steps, don't do it. This isn't a good time. If you try to do too much in your head, you'll end up with boo-boos on this stuff. At least that's what I've seen. Okay, now I'm going to multiply I times both of those, which is going to give me 2i plus I squared. Okay, that's the top. Okay, now for the denominator. 2 times 2 plus I would be 2 plus I. No, it wouldn't. It would be 4 plus 2i. Negative I times 2 would be minus 2i. Negative I times I would be negative I squared. Okay, now watch the magic. In the denominator, to get those i's to go bye-bye, there's 2 i's are opposites. They're going to wipe out each other. Cancel each other out. The top, I'm going to do replace I squared with negative 1. So I'm going to have 10 plus 7i plus negative 1 or minus 1. In the denominator, I'm going to have 4 minus negative 1. Okay, remember to place I squared is equal to negative 1. So now I'm going to do 10 minus 1, hence I just said the answer, 9 plus 7i, and 5 minus negative 1, I just said the answer again. 4 minus negative 1 is 5. To separate this into an a plus bi form, you would have 9/5 plus 7/5 I. That's a plus bi form. Okay, here we go on the next one. 1 plus I is the multiconjugate of 1 plus I is 1 minus I. Do that to the numerator and denominator. Multiply 3 times both terms gives us 3 minus 3i. Multiply negative 4 times those, we get minus 4i plus 4i squared. In the denominator, you're going to have 1 minus I squared. Do you mind that I didn't write the middle terms? They cancel out. Okay, now replace your I squareds with negative 1 and combine any like terms. So I have 3 minus 7i plus 4 times negative 1. And I got 1 minus negative 1 on the bottom. 3 plus negative 4 is what we'll have at the end. So that's going to be negative 1 minus 7i on top, 2 on the bottom. And then if I rewrite that in real plus imaginary, it'd be negative 1/2 minus 7/2 I. Okay, how are we doing? Okay. What do you think we should multiply numbers 20 by? There you go, negative 7i. Okay, 3 times negative 7i, negative 21i, minus 14i squared. And on the bottom, negative 49i squared. Replace our I squareds with negative 1. Gives us 21i plus 14 on the top. That's a weird looking 21. I don't know why mine looks so weird. Let me rewrite it. Okay, that was negative 21i plus 14 on top. And on the bottom, that's going to be negative 49 times negative 1, which I get positive 49. Now I'm going to rewrite it in a plus bi form. So I'm going to write 14 over 49 first, and then minus 21 over 49i. And then realize that we can reduce these, right? So we should. It's going to be 2/7 minus 3/7 I. Okay. That is proper a plus bi form. Find the values of x and y that make the statement true. All you'll do is take the first part, set it equal to the real part. So 2x is equal to negative 14. Take the y part with I in it, set it equal to the other part with I in it, negative 3i, and then solve. So this would be x is negative 7 and y is negative 3. Made it look really easy, right? Some of you could probably look at these and tell that this is going to be negative 2. You get what I'm saying? So, but here's solving it algebraically. Negative 3x equals the sixth part. X is negative 2. Negative 5yi equals negative 20i. My eyes are very strange this period. But anyway, we divide by negative 5i, and we'll get y is 4. Okay. Now, what's the point? Here we go. We're going to solve quadratics that have complex numbers answers. So we would subtract 5, take the square root, which would be positive or negative, square root of negative 5. Pull out your I, write it down, times the square root of 5. So plus or minus I times the square root of 5 is the solution to that quadratic. Second one, subtract 24, divide by 4, take the square root, positive or negative, I times the square root of 6. I bet you could do these just like you know how to do the other ones. You probably do these really fast now. You just know there's a new answer type, which is going to be the complex. Next one, 25. Subtract 84. Divide by 7. Take the square root. Plus or minus 2i times the square root of 3. And the last one, plus or minus I. You know I got the 2 root, right? Any questions about that? I did the square root of 12 is 4 times 3, 2i times the square root of 3. That's where I got my plus or minus 2i root 3. Application of this would be for electricity. Oh, let's do these first. I forgot that was next. I was thinking that applications were next. Okay, here's that pattern. Remember I said, look, you want to memorize through I to the 4th. Okay, so I to the 4th is a big deal. How many I to the 4ths are there in I to the 20th? Okay, so here's your key spot right there. So if I go 20 divided by 4, I would say 5, and so that's I to the 4th to the 5th. By the power of a power rule, you can rewrite I to the 20th side of the 4th raised to the 5th power. I to the 4th is 1. You memorize that. So I've got 1 to the 5th. The answer is 1. Or you can do it this way. 4 goes into 20 evenly, so it has no remainder. I to the 0. What's anything to the 0? 1. Okay. Break this one up. I to the 4th to the 7th would be I to the 28th. 31 minus 28 is 3, so I've got I to the 3rd left. Remember, that part's just 1. So the answer is I to the 3rd, and I to the 3rd equals negative I. I did. What do you mean? I guess, well, I don't get the point, though. I'm confused. Tell me what you said again. Oh, okay. Well, you could, but I just thought this was easier. That was just my opinion. But then, if you're getting the answer right, that's great. You know, it's not the only way you could do it. You know, I could break it up in a whole million different things and get it figured out. I mean, I could break it up a lot of ways and figure it out. But I was trying to do one way, so I was sticking to the I to the 4th remainder, and then that would be which power within that list. So that's why I'm dividing by 4, and then the remainder is the answer. So it'd be I to the 3rd, and that's negative I. But Scott, if you get it another way, it doesn't bother me. All right, electricity voltage is equal to the current times the impedance. Maybe that's a better way to say it. Sounds all right. Better. Find the voltage in a circuit with the current is 2 plus 4 J amps, and the impedance is 9 minus 3 J ohms. Now, J stands for joules. You've seen that in science probably. All right, so let's find the voltage. So we're going to take 2 plus 4J, and J is just like I in electricity. And times 9 minus 3J, just like an I. We'll get 18 minus 6j plus 36j minus 12j squared. All right, then we combine our like terms, replace j squared with a -1. So that's going to be 18 plus 12, which will be 30, and -6j plus 36j is plus 30j. And the second one says a current in one part of a series is 5 minus 3j amps, and current in another part is 7 plus 9j amps. Find the total current. That's going to be add. So we're just adding the two currents to get a total. So that's going to be 12 plus 6 joules. I just want to say joules because of how it's spelled. Last one in the notes, right? Okay, so what you see following that is the book assignment, which is due on Friday. Okay, it is part of the homework check on Friday. Today is Tuesday. Quite a bit of time. However, you're going to want to be able to answer questions by Thursday. Okay, you really need to have it done by Thursday. So tomorrow we'll talk about the quiz preview. You want to do your worksheet 17. That's probably the main thing in this stuff. Okay, worksheet 17 in this. We're going to check worksheet 17. We'll have tomorrow and the next day to do some work and ask questions, etc. But to do some at home, and we'll have some puzzles, and we're going to quiz on Friday. Timer time's done for today.